Hey guys, this is your Madam Vash and welcome to my channel. As a continuation from part 1, I'll be discussing slightly more challenging questions on buffer. Let's get started. Here's the first question. Pause the video and have a read. This question requires you to calculate the ratio of concentration of ammonia to ammonium chloride needed to form a buffer solution with pH 8.5. The ratio of concentration of ammonia to ammonium chloride can be translated as such, and mathematically this means concentration of ammonia divided by concentration of ammonium ion. The division of a base concentration with conjugate acid concentration is found in the Henderson-Hasselbalch equation. Since ammonia and NH4+ makes a basic buffer, thus pOH must be calculated as shown. Continue the calculation by substituting in the corresponding values into the Henderson-Hasselbalch equation. And if you notice, the Henderson-Hasselbalch equation actually gives the ratio of conjugate acid concentration to base concentration. Since the question is asking for base concentration over conjugate acid concentration, do an inverse. And here's your answer. Moving on to the next question. Pause this video and have a read. Here, the pH of a basic buffer solution is given together with the volume and concentration of the base. You are required to calculate the amount of conjugate acid needed. First of all, identify the conjugate acid and weak base present, as well as, since it's a basic buffer, calculate the pOH value. In order to connect the required information with the given information pH, we'll be using the Henderson-Hasselbalch equation. By substituting in the values like pH, Kb and base concentration into the Henderson-Hasselbalch equation, we'll be able to find the concentration of the conjugate acid. Answering this question does not stop here. Amount of NH4Cl refers to the mass of the salt. Thus, in order to calculate mass, we require number of moles and molar mass. Using the concentration found previously, we are going to calculate the number of moles of NH4Cl using the mV over 1000 formula, and molar mass is calculated by using the relative atomic mass given in your table. Calculate the mass of NH4Cl by multiplying the number of moles with the molar mass. Now to the final question in this series. Pause this video and have a read of this explanation type question. In this question, an acidic buffer combination is given and you are required to explain how this buffer solution is able to maintain its pH even when a small amount of strong acid or a strong base is added to it. Begin the question by explaining the dissociation that happens to the weak acid, whereby H2CO3 undergoes partial dissociation as shown. When a small amount of strong acid is added to this buffer solution, H+ ions dissociated from this strong acid reacts with the conjugate base. For this reaction, do include its equation. H2CO3 is a weak acid, therefore only small degree of ionization occurs, thus pH of the buffer solution is maintained. Next, if a small amount of strong base is added to this buffer solution, hydroxide ions dissociated from the strong base reacts with the weak acid present. With the explanation, don't forget to include an equation showing OH- reacting with H2CO3 to produce HCO3- and water. As a result, the concentration of hydroxide ions decreases, thus pH of the buffer solution is maintained. Thank you for watching this tutorial. I'll see you in the next.